Hello, this video is on the classification of matter. So when I say the word matter, I want you to be able to instantly think of this definition. So essentially what I want you thinking is that matter is just a description of anything that is physical that actually occupies space. So when we talk about the word matter, probably what you're thinking of is one of three phases. And so the common three that we talk about are solid, we also talk about a liquid, and we talk about a gas. And so these are three different phases of matter. So solid is something that's packed really, really tight. It has a small amount of kinetic energy. The distances between the molecules within the solid are fairly close together. A liquid, the molecules are a little bit further apart, and so it has a little bit more kinetic energy. And then a gas is even further spaced apart, so it has tons and tons of kinetic energy. But essentially what I want you to be able to do today is when I talk about matter, I want you to be able to break it down into a number of different pieces, or maybe different vocabulary, just different words and classifications. So what we're going to do right now is kind of go through that just to make sure that we're all on the same page for this entire course. So let's start off with something very, very basic. So matter is our global topic today. And so we can easily separate this into two different sections. So we either are going to have something that is pure, or we are going to have something that is a mixture. And so a mixture is something that's a little bit more complicated, so we're going to come back to that. But right now I want to focus on something that is considered pure. So one piece, one thing, one section of matter. So this would be an example of maybe like sugar or maybe flour or something if you were cooking, whereas a mixture would be your cookie dough. So you've put that together with your flour, your eggs, your sugar, your baking soda, obviously chocolate chips, you need something delicious. But that's just the difference. So pure, it's one thing, your flour, your sugar. Your mixture is a number of different things that have been put together. So we can actually take a pure substance and break it apart into two very distinct sections. So one of them is what I would call an element, and the other one is what I would call a compound. So an element is the simplest of everything here. So it's just a group of atoms that are placed together, and they all have very, very similar properties. But when we say element, we're really talking about one thing. It is one specific thing. Maybe we're saying sodium, maybe we're saying chlorine, but it is one element. It is one group of atoms that all have the same number of protons, the same number of electrons, but it is very, very simple, and we keep it as one piece. However, a compound is essentially what it is. It's a combination of elements. So for a compound, I would say this needs 2+ elements. Okay, so a very classic example of that would be sodium chloride, otherwise known as table salt. So this has two elements in it, sodium and chlorine. Each one is an element by themselves, but together, when they're bonded together with that ionic bond, they form a compound. So these are two very, very different things that we need to be super careful of and make sure we understand the differences. So now, if we talk about an element, we can actually break that apart into three different sections. So one of these things, or one of these labels, would be called a metal. Another one of them would be called a metalloid. And the last one, I'm going to kind of reach all the way over here, would be a nonmetal. So we have three different labels that we like to say for an element. So again, an element is a group of atoms together with the same property. Now, when we talk about these things, they're either going to be considered a metal, a metalloid, or a nonmetal. And so a metal is something that has very, very distinct properties. So a lot of times they're shiny, and a lot of times they can conduct heat, but more importantly, electricity. Whereas a nonmetal is typically something that is not shiny. Or it's not shiny, that would be an I. There's something that cannot conduct heat, so I would just say no heat, and cannot conduct electricity, or no electricity. A metalloid is somewhere in between. So it's something that you can't specifically say is shiny, conducts heat, and electricity. Maybe it's something that is shiny but can't conduct heat and electricity, or it's something that conducts heat but not electricity. So a metalloid is something that's in between. And so what I hope you can do is eventually, if I were to give you a periodic table, I would hope that you would be able to identify which part of these pieces are metals, nonmetals, and metalloids. So right now, we're going to go into the periodic table way later on, and so don't worry about this part right now. But right now, all I want you to know is that a periodic table is something that contains a number of different elements. It's all the elements that we have found up until this point in time, but it's organized in a certain way so that things have a certain property. But essentially, all I'm looking for right now is so that you could be able to kind of circle a section. So all the way up to about here-ish, it's not perfect. These are considered your metals. So these are the ones that are shiny, they conduct heat and electricity. Then over here on this side, kind of like this, and again, not perfect, these are our nonmetals. So these are the ones that are not shiny, they don't conduct heat, they don't collect electricity. And then there's 8 different elements here in the center that are considered our metalloids. And so a lot of these are very simple, but again, you can't classify them as either a metal or a metalloid, or a non-metal. They are considered metalloid because they have properties somewhere in between. So the 8 ones that I want you to be able to pull out are boron, silicon, germanium, arsenic, antimony, tellurium, polonium, and astatine. So those are your 8 metalloids. So right there are your metalloids. So I think it's very, very important and very useful that you are already able to pull these pieces out. We're going to talk about this way deeper later on, but for right now, this is what I want you to be able to do. So right now, just to check in, I want you to see and test your understanding, see if we understand what's going on. So let's look at this. Complete the following sentence. Elements can combine chemically to form what? Complete that sentence. All right, did you form it? Did you figure it out? Hopefully the word you put in there was compound. Yay! Compound is the correct word. So elements come together and they form a compound. The only thing we need to know for a compound is that it must be 2 or more elements. So if I gave you something like nitrogen gas, such as N2, that only has 1 element in there. So that's actually just considered a molecule. So this would not be a compound. But something like SO4, something like sulfate, that is 2-, that's definitely a compound, and so on and so forth, like sodium chloride is. So now the last thing I want to do is go back up here where we were talking about mixtures, and we need to introduce 2 more terms here. So for a mixture, we typically use the 2 words homogeneous or homogeneous, or the opposite of this, heterogeneous. And so these are 2 very, very distinct ways to describe a solution or a mixture, something that is not pure. It's not just an element, it's not just a compound. Maybe it has a number of different compounds or a number of different elements that are not chemically bound together. So something that is homogeneous, we can look at this word homo right there. This just means one. It's one piece, it's one solution, it's one phase. Whereas something that is heterogeneous has to have at least 2 phases, and sometimes it has more. And so the best way for me personally to describe this is I like to use an example. So here I have just a flask. It's an Erlenmeyer flask full of water, and I'm going to just take some food coloring and put it in here. So right now I'm just going to add maybe 1 or 2 drops. So right now we can very clearly see the water here, and then you can see the green food coloring that's added in. So I'm going to kind of step back, get away from the expensive stuff, my tablet here, and I'm going to swoosh. And now we can only see one phase. So in the beginning, when we have the food coloring and the water, that's considered a heterogeneous mixture. You can very clearly see 2 different phases. Now, no matter how I look at this, it all looks like a beautiful green solution. This would be considered homogeneous. So the last thing I want to point out for a mixture is that a mixture can sometimes be separated physically. So maybe if we had salt water, if we went to the ocean and collected a scoop of salt water, if we boiled the water would eventually evaporate. It would go from the liquid phase to the gaseous phase, but our flask would be left over with a solid salt at the bottom, so we could actually physically separate our mixture. So we can't always do that with compounds. With compounds, we need to separate them chemically. So we have one more question for you here, and thank you very much. Have a good day.